real quick. If you're at home watching this, you're going to have to pause because I'm just going to show you these real fast. You have to know what rational numbers are. Here's a few examples. 6/8 is not rational because it can be reduced. And then here's some examples or reminders of square root of 9 is square root of 3 squared, which is 3. Cube root of 8 is cube root of 2 squared, which is 2, because 2 cubes equal to 8. And then we start looking at this as a rational exponent. Okay, and so if we go down now, what is the fifth root of x? How can I write that as a rational exponent? X to the 1 over 5. That's correct. So sometimes your questions will simply ask you to rewrite it as a rational exponent. So you take that and you rewrite it instead of the fifth root, we rewrite it as x to the 1/5 power. Okay? And then back up to here, when raising a power to a power, we said we multiply exponents. We remember that from before. And then 3 over 1 times 1 over 3 is equal to 1. So we get the third root of 8 is equal to 2. Now here's the rule. I'll pause this while you copy that down, and then we'll explain what it means. So it says the nth root of a number is a real number, and the m is an integer. The nth root of a is a real number, and m is an integer. Then a to the 1 over n is equal to the nth root of a, and a to the m over n is equal to the nth root of a to the m. Or you could write it as nth root of a in parentheses to the m. What I want to make sure that you're catching on to here is that notice where this goes in the fraction or in the rational exponent. What part of the fraction is that root, Jared? What part of the fraction is the root? So the n is the root, right? The index. And so where does that go in my fraction? Here's the fraction.
Isn't it power?
Here's the fraction. Where's the n going? N. Where's the n at in the fraction? I mean, look at the fraction 1 over n. Where's the n at? On the bottom. So it's the denominator, right? So, and the root becomes the denominator, doesn't it? You need to realize that. In the power inside, where does that go? The numerator, right? What's the power on this a? A 1. And look what's up there. A 1. Okay? So make sure you realize when you're transforming this from one to the other, the power goes to the numerator of the exponent. The root goes to the denominator of the exponent. And so if we rewrite this one right here, this becomes x to the what? 5 over 4. Remember, the root becomes the denominator. The power becomes the numerator. The index is always the denominator of the fraction. The index, the root, is always the denominator of the fraction. So what's this one going to be? X to the 3 over 5, or x to the 3/5. Okay, that's correct. Yes.
So there's no difference at all if the 3's there or it's on?
No. No, remember, here we're raising a power to a power, right? So this would be x to the 1/5. To the third power would be x to the, remember that's 3 over 1. Multiply them, 3 over 5. So it makes no difference if there's parentheses and the power's outside or if the power's inside. Makes no difference. Okay? That's why I want to make sure I showed you examples here that were one of each so you realize that they're not any different. You treat them the same. Okay. Any questions on that? Write the exponential expression in radical form. Write the exponential expression in radical form. So take a moment real quick and write x to the 2/7 in radical form. So you went 7 square root of x squared? Does he mean to say 7 square root?
No.
What's he probably have written on his paper? 7th root, right? Remember, this radical sign is only square root if there's nothing there, if that's a 2. If you're putting a 7 there, it's not a square root, it's a 7th root, right? Is that what you had written? Okay, I thought you probably did. And then you said inside was was x squared?
Yes.
I agree with that. Okay? The denominator becomes the index, and the numerator is the power to the variable. Okay? Good. Now, why is this one here different than every other one we've looked at so far? It's negative, and doesn't have a fraction. It has instead a decimal. 4.4 is read. How do we read that properly? 4/10. So let's write it that way. 4/10. Is that rational?
No.
Not yet. What do we have to do to it? Reduce it. What's it become? 2/5. So this is the same as negative 2/5, isn't it? Yes? It's still different than every other problem we've done because Molly said it is negative. Right? It's negative. Let's deal with that negative. Sorry. I'm thinking through all the scenarios of how the best way to deal with this in my head, and I'm not coming up with a quick one. So let's first of all rewrite it as what goes out here? 5. I agree with that. Let's keep that negative inside for now. Like this. Okay? I'm really, if they gave you a question like this, I'm not 100% sure on how they would want you to leave the answer. Because, let's go back to something a little simpler. X to the negative 2nd power. Remember, negative exponents don't mean negative numbers. They mean reciprocal. So this really means 1 over x squared. Okay? If I have 2/3 to the negative 1, that means I have 3 over 2 to the positive 1.
Oh.
Okay? Remember, they mean reciprocal. Negative exponents mean reciprocal. It doesn't mean negative numbers. If this is a positive 2/3, and this means I take the reciprocal of that, which is going to be 3 over 2. Okay? So, that's why I'm saying here I'm not quite sure how they want you to deal with this, because if I dealt with this, then I would say that's the 5th root of 1 over y squared, and now I have a square root symbol in the denominator, don't I? I really have 1 over the 5th root of y squared, and I don't think that at this point they're wanting you to deal with trying to I don't think they want you to deal with trying to rationalize that denominator right now. That's not the point of what we're doing. It's not the point of what I'm doing. Okay. But anyway, I think we would just leave it like this. Okay. I don't think we want to get into that yet. All right. Do you have any questions on how we change that to 2/5? The fact that the negative doesn't mean we're talking about a negative y value. Okay. Write in simplest form. Here's a reminder of the rule you learned in algebra. A to the n, b to the n is the same as ab to the n. And so what that means is I distribute my n power to every factor inside. And so I can do that here also. So I get x to the 2/3 times negative 4/1 and y to the negative 1/4 times negative 4/1. Now the reason I put the negative 4/1 was because I had fractions inside there. And I want you to remember that when you multiply fractions, you multiply top and you multiply the bottoms. And so I get x to the negative 8/3, y to the 1. Just 1. Okay? Now, if they want this left in rational form, they would want you to deal with this negative. In this case, they're saying reduce to or write it in simplest form. So this is positive, so that stays in the numerator. I don't need to write the 1 there, do I?
No.
Okay. And this is negative, so it means I move this down to the denominator. So I get x to the positive 8/3. I'm going to rewrite that so it's easier to see. Okay.
I don't think I can do that.
You can do it. All right? It's just a matter of practicing them a little more until you see more of them. It looks way harder than it is. But the key is you do need to practice them. I mean, it's whoever first said that math is not a spectator sport is right on. You can enjoy and learn a lot about basketball and football and baseball by watching it all the time. You don't learn a lot about math by watching. If you don't practice it and do it, you won't learn it, you won't remember. Okay? If they asked us to write it in radical form, then we probably wouldn't deal with moving it to the denominator. It would create some irrational numbers. But I didn't mean that. It would create radical signs in the denominator. All right, that's not really true. That assignment is from lesson 5, not 4. Okay. You can just add these right to your notes you're on. We're going to look at 7-5 notes real quick. Just parts of them. We'll finish them up tomorrow. Okay? It says I can solve radical equations. I can solve radical equations. Okay? I can solve radical equations. Can I move on? Here's two examples of a radical equation. It has to have a variable in the radicand, or it has to have a variable with a rational exponent. So these are examples of radical equations. I have a variable with a rational exponent, or I have a variable with a radicand that is a variable. this one down here, I'll move it back up a second. This one down here is not a radical equation because my variable is not the radicand. This is just a number, square root of 5. It's not a pretty number, but it's just a number. I can solve this just by subtracting square root of 5 from both sides. That's the equation. That's the answer. Okay? Up here, I can't do that. All right? So it's important you realize a radical equation is an equation that has a variable in the radicand or has a variable with a rational exponent. Okay? I'm going to do a couple examples like number 1. That's all we're doing. Okay, a couple examples like number 1. And I have a few, then tomorrow we'll do some examples like number 2. And we'll talk about extraneous solutions, which we sometimes will get. Okay? Anybody not ready for me to move on? Okay, let me add a page here because I'm sure I don't have a lot of those examples. So, let's start out with the most basic one. Square root of x is equal to 4. So is x equal to 2? No, it's not. So look at this like we do every other equation. What are they doing to the x? Square rooting it. How do we undo square roots? We square it. We square both sides. So we square this and we square this. And so when we square a square root, they cancel, leaving me with x equal to 16. Now if I had x squared equal to 4, then I would square root both sides, wouldn't I? And I wouldn't know what that number was because it was being squared. I wouldn't know if it was a positive or negative. This is not the case. Okay? This is not the case here. We do not worry about plus or negative here. In fact, if I put a negative in there, what would that create? What's the square root of negative 16? Can't do it and get real numbers, can I? They're imaginary, aren't they? All right, so this case, the answer is 16. That's all there is. Now, let's move up one step onto that. Square root of x plus 4 equals 5. Okay? Here's the rule. Before you can undo the square root, we must isolate the square root. Meaning we must move everything over to the other side except for the square root. And so when we do that, I will have to move what here? Okay, by subtracting 4 from both sides, right? And so I get square root of x is equal to 1. Now I have the square root all by itself. Cody, what should I do to get rid of that square root sign? What did I do up here to get rid of my square root sign? Go ahead. Go with the guidance you're getting. You squared it. Right here I had square root of x, and I squared it. I squared both sides. So down here, same thing. I get down to square root of x, and I have to square both sides. And when I square x, square root of x, the square root and the square cancel, leaving me with an x. And when I square 1, I get 1. So x is equal to 1. Check it out. What's the square root of 1? 1. 1 plus 4 is 5. It works, doesn't it? Okay. Square root of 2x minus 3 equals 5. Square root of 2x minus 3 equals 5. Okay, do I have to isolate my square root? Okay. It's already isolated, isn't it? Because all of this is where? Inside the radical sign, isn't it? So it's already isolated. So once it's all by itself, you go right to squaring both sides. And so when I do that, the square root and the square cancel, leaving me with 2x minus 3. When I square this, what do I get? 25. Now I need to solve like you would any other normal equation. Add 3 to both sides. 2x is equal to 28. Divide by 2, x is equal to 14. Okay? That makes sense, Haven? Think you can do the next one? Square root of 5x minus 4 plus 2, oops, let's add a 3 up here, equals 7. This is as complicated as they're going to get today. In fact, no, it's about as, maybe a little more. 3 out front. 3 times square root of 5x minus 4 plus 2 equals 7. Matt, you okay? Oh my gosh, I thought you were going to drown. It's raining out. You have to be careful. You know, that's what happens, poor young turkeys. In the rain, they drown. They think moms are trying to give them food, and so they hold their head up to the sky, and they open their mouth, and then the rain falls in their mouth, and they drown. Isn't that sad?
Is that really?
It is really true. Yeah, really true. Sad, but true. All right, so what do you think? Haven, you go first. What do you think the first step should be? Excellent. Good answer. That's correct. Can someone tell me why we're doing that first? Getting the square root all by itself. We're isolating the square root. So we get 3 square root of 5x minus 4 equals 5, because we have to subtract 2 from both sides, right? Chase, can you tell me what should I do next? No idea. Do we have the square root all by itself?
No.
Now, what's in the way of having that, Chase? Listen to Alana. She's trying to shout it out. Okay. What's in the way of having this square root all by itself? The 3. What are they doing with the 3 and the square root? Multiplying, and how do we undo multiply? We divide. Probably what's confusing to you here is the fact that I picked a number that's not very nice. So we get, I'm sorry, that's a 5, not 2. Square root of 5x minus 4 equals 5/3. Okay, what do we do next? Square both sides, because I do have this by itself now. So I square both sides. And I get 5x minus 4 equals 25 ninths. You agree with that? Square 5/3, that's 5 times 5 over 3 times 3. Now what do I do? I heard somebody over here say it. Add 4. So 5x is equal to, do you agree that 4 is 36 ninths? Do you agree that 4 is 36 ninths? 36 divided 9 is 4, right? So we're adding to 25 ninths, we're adding 36 ninths. That's what 4 is. Right? Remember adding fractions? Okay? So I get 5x is equal to, is that, whoops, there, 61. I can't add. 61 ninths. Now what do I do? Yeah, except I have a fraction over there, so instead I'm going to multiply by 1/5. And 5 doesn't go into 61 evenly, so I'm just going to leave it as 61 over 45. They won't give you one that ugly. I just made up the number and it didn't work out. Okay. So, today, we're going to do this. 1 through 6, 34 and 35. Let's just go 34, because we haven't talked about 35 yet. We'll save that one for tomorrow. So do those 7 questions. Do them right away. You have time. Okay? It's either work on those 7 questions or I give you the quiz I have copied off. Your choice, Chandler.
I'm getting there.
Okay. Oops, I think we're still recording.